Today we're going to continue looking at properties of logarithms. The first property we'll start with is the product property. And the product property says if you have log base b of x times y, you can separate this into log base b of x plus log base b of y. It's important to recognize that the log and the base, when you separate it using addition, you include the log and the base with each part. So if you have an argument that's multiplied together, you can separate this with addition. Next, we have the quotient property. And the quotient property says if you have log base b of x over y, you can separate that with subtraction. Log base b of x minus log base b of y. Of course, you keep the log and the base with each part when you expand this function. If you have division included in your argument, you can expand the function with subtraction. And the last one for this section is the power property. And the power property states that if you have log base b of x raised to the power of p, you can rewrite this with your exponent of p in front of your logarithm, restating this as p times log base b of x. So in this case, log base b of x remains, and your exponent becomes your coefficient. For the first example set, it says to express each logarithm in terms of ln2 and ln3. So it's telling us that we want to separate these logarithms or expand these logarithms using 2 and 3 as our argument values. So these will take a little bit to understand or figure out how to rework the number in order to use them. But the first one is ln of 54. So just to break this down to something to get us started, I'm going to break 54 down to 2 times 27. And from there, I'm going to recognize that 27 can actually go a little bit further, and we can write that as 3 cubed. At this point, I recognize that I have an argument, that's this term here, that's multiplied together. So if you're multiplying the argument, then you can use the power property. And the power property indicates that you can separate or expand your logarithm using addition. So I'm going to write this as ln2 plus ln of 3 cubed. Now I have this exponent with 3 cubed, and this indicates that I can use the power. Sorry, I wrote this wrong up here. I wrote power property up here, but it should be product property. I just realized I did that. And this is the power property. So the power property says you can rewrite that exponent in front. You only write it in front of the expression that it's specifically with. So it only goes in front of ln of 3. That exponent that I highlighted in green is rewritten right here. Okay, this is your final expanded answer. We can't go any further. We don't have any more multiplication, division, or exponents. So once you get rid of all your multiplication, division, and exponents, that is your final expanded answer. For number 2, we're still using ln of 2 and ln of 3. In this case, we have division, but we also have 9 over 8. So I'm going to start by separating this as 3 squared divided by 2 cubed. Because we have division right here, that indicates we're going to be using the quotient property. And the quotient property says we can expand division using subtraction. I can write this as ln of 3 squared minus ln of 2 cubed. Now that I have exponents, I can use the power property. And the power property allows me to write those exponents in front of the function. So this 2 is actually going to become 2 times ln of 3 minus 3 times ln of 2. And that's your final expanded answer. There is no more there's no more multiplication, division, or exponents. For the on your own section, you're asked to express the logarithms using log of 5 and a log of 3. So I already included my answer here just to save us a little time on the video. But for number 1, it's log of 75. So I started by breaking that down to 25 times 3. 25 is 5 squared, and you can check over the rest of that. Number 2, we also need to use 5 and 3. So 27 divided by 5 became 3 cubed divided by 5. For problems like these, you have to work around what you know. You might have to look at it a couple of different ways, but make sure you always use the indicated values. In this case, it's log of 5 and log of 3. Okay, before I start the next section of practice problems, just recall the previous properties that we went over. This was when we first learned about logarithms. We had the property that states that log base b of 1, regardless of the base, will always be 0. Log base b of b will always be 1. B raised to the power of log base b of x, regardless of the base or the value of b, will always be x. And log base b of b raised to the power of p will always be p. Also, remind yourselves that ln is the same thing as log base e, and that's helpful sometimes when you're simplifying. For the next example set, we're asked to evaluate the logarithm. We need to use everything that we know. So we need to use the 3 properties we went over on the first page, the product, quotient, and power property, and also these 4 properties that we previously knew. So number 1, we have log base 4 of 64, or the 5th root of 64, which I'm going to rewrite the 5th root as an exponent. I'm going to rewrite this as log base 4 of 64 raised to the power of 1/5. From here, I'm going to rewrite 64 as 4 cubed. The reason why I'm writing that, or the reason why I know to write that, is because I'm looking at this base right here, and the base is 4. So I'm thinking if there's anything else I can do to simplify this. I recognize that 64 can be simplified to a base of 4. I'm going to write this as log base 4 of 4 to the power of 3 raised to the power of 1/5. When you have double exponents, you can multiply those exponents together. Log base 4 of 4 raised to the power of 3 over 5. And now this right here, we're allowed to use the equation or the property number 4 that we went over, which tells us if we have a log with a base and an argument that are the same, your solution will be your exponent. So in this example, our solution is 3 over 5. Now that's not the only way that you can solve for this. I could have rewritten this with the exponent in front using the power property, and I could have at that point converted the value of 64 to 4 cubed. There's multiple different ways to solve for this, but regardless how you do that, you're going to end up with 3/5 as your final answer. Anytime you have a problem like this, you're going to see more like that. If it's a radical, change your exponent or change your radical to an exponent. If you have a base, try to match that base. So just a few helpful tricks or helpful tips in order to solve problems like this. Number 2 is ln of e to the 9th plus 4 times ln of e cubed. So the only thing I recognize to do first is to convert my exponents using the power property. I'm going to write this as 9 times ln of e plus, I already have a value of 4 right here, so I need to multiply this, 4 times 3 times ln of e. The 9 value was originally the exponent, and this 3 value was originally an exponent. ln of e we can rewrite as log base e, and if we take a look at property number 2, if you have the base and the argument that are the same, your solution is going to be 1. So by rewriting ln as log base e, we still have that argument of e. That's going to be replaced with a value of 1. 4 times 3 is 12, and we're replacing ln with log base e. Our argument is still e. So at this point, I just replaced ln with log of e. And next I'm going to recognize that log base e of e, both of these, is property number 2. It's going to simplify to a value of 1. This becomes 9 times 1 plus 12 times 1, or 9 plus 12, which is equal to 21. This section right here, simplifying logarithms, is definitely one of the more challenging ones to figure out how to do because you have so many things coming together. You just have to work at them slowly. There's, again, multiple ways to solve for them. You may have done these problems different than how I did them, but arrived at the same answer. That's totally fine. At this point, we have 7 different properties. The 3 on the first page, these 3 properties, and the 4 that we already learned. So you're bringing all of those properties together in order to solve problems like this. In the next section, our directions tell us to expand the logarithms. So this is using, again, all of the properties, but it's primarily going to use the 3 from the first page. So the first one, we have log base 4 of 7 times x. This is 7 times x. This is the product property. When you have multiplication, you can separate that with addition. Remember to include the logarithm and the base for each part. So this becomes log base 4 of 7 times log base 4 of x. And that's all you can do here. We don't have division, we don't have exponents, and we don't have any more multiplication. So that's your final check when you're simplifying these. Check for multiplication, division, exponents. If you have them, you need to do something with them. Number 2 includes the quotient property. We have division right here. The quotient property can be expanded with subtraction. Log base 2 of d minus log base 2 of x cubed. This exponent is going to be the power property. So the power property at this point is usually one of the last steps, but it is specific to the problem. So you can't always say it's going to be the last step. You could have an exponent around your entire function. That's a little bit different. But these ones here, it is the last step. It only applies to this x value, so therefore you have to do that last. Your final answer is log base 2 of d. This value of 3 is going to become our coefficient, so minus 3 times log base 2 of x. Number 3, log base a of x times the square root of x squared plus 1. So right here is multiplication, which is the product property. That's where I'm going to start. I'm going to break this apart as log base a of x plus log base a of the square root x squared plus 1. Now, anytime I have a radical, I'm going to rewrite as an exponent. If I rewrite this as an exponent, my function becomes log base a of x plus log base a of x squared plus 1, raised to the power of 1/2. Now that I have an exponent of 1/2, I can rewrite that in front of this function, or this expression, for my final answer of log base a of x plus 1/2 times log base a of x squared plus 1. Now, if you're wondering why we don't separate x squared plus 1, you can only expand multiplication, division, or exponents. You cannot expand subtraction or division. And for this last one, we're going to start with the quotient property. I do notice that I have exponents, but these exponents are specific to each value, meaning this 2 only applies to that value of x, and this 3 only applies to x minus 1. So starting with the quotient property gives us ln of x squared minus ln of x minus 1 cubed. Then I take care of those exponents, giving me 2 times ln of x minus 3 times ln of x minus 1. So you need to always check for multiplication, division, and exponents. Once you eliminate all of them, your function is completely expanded. Here are my answers for the on your own section if you want to check over those. And next we're working on condensing logarithms. So this is actually working backwards. It's where we have addition and subtraction, and then we need to reverse it, putting it back to either multiplication or division. Also, if we have a coefficient, we need to reverse that back to an exponent. Before we start, whenever you're condensing, you need to make sure your bases are the same. Number 1 is log base 10 of 6 minus log base 10 of 2. I know those bases are 10 even though we don't write them. I also see that I have a subtraction sign. Subtraction is the reverse of the quotient property. Remember, multiplication and addition go together. Division and subtraction go together. So I can simplify this to log base 10 of 6 over 2, which actually simplifies to log base 10 of 3. So you're working in the opposite direction. If you have coefficients, you need to reverse those back to exponents before you can do anything. So always check for your coefficients first. That gives me log base 3 of x raised to the power of 4 plus log base 3 of y raised to the power of 2. All right, because I have addition, addition is the opposite of multiplication, so this is the product property. I should probably indicate up here that we use the power property. So knowing that I have addition, I can write this as log base 3 of x to the 4th times y squared. This is your condensed answer. It's your simplified answer. Number 3, 6 times ln of x minus 4 plus 3 times ln of x. We're going to start with the power property. Rewriting this as ln x minus 4 raised to the power of 6 plus ln of x raised to the power of 3. The addition sign indicates product property. I can write my final answer as ln x minus 4 times 6 multiplied by x cubed. I would probably like to reverse these right here, just because I think it would look a little bit better if we wrote it as ln of x cubed times x minus 4 to the power of 6. But either way, it is the same answer. Number 4, 4 times log base 3 of x minus 1/3 log base 3 x plus 6. Using the power property, we're going to rewrite this as log base 3 of x to the 4th minus log base 3 of x plus 6 raised to the power of 1/3. Now that I took care of the power property, I have subtraction, which corresponds to division. Log base 3 of x to the 4th divided by x plus 6 raised to the power of 1/3. There's one thing you need to notice on the denominator for this problem. Anytime you have an exponent, anytime that's a fraction like this, if you can convert it back to radical form, which you can on this one, you need to make sure you do that. So our final answer is log base 3. Our numerator is x to the 4th, and our denominator becomes a radical, the cube root of x plus 6. I almost missed that on this one. But if you have a exponent that can be expanded or condensed all the way back to a radical, then please do that. And here's my answers for the condensing logarithms if you want to take a moment and check over those. And the last part of today's notes is working with the change of base formula. So over here on the side, you see I wrote out a note already. and it says sometimes you need to work with a log that has an inconvenient base. For example, log base 3 of 5. This presents a challenge because calculators do not have a key for evaluating base 3. When this happens, you need to use the change of base formula. This formula comes in super helpful in many ways. It allows us to type in different equations into our calculator that are not base 10. So what that's saying is if you have a logarithm like this here, log base b of x, you can rewrite this as log base, I have a in here, but a can be represented as 10. So your argument becomes the argument in the numerator, and the base becomes the argument in the denominator. So log base a that I have written for our standard form can either be log base 10, which is in your calculator, or log base e, which is actually ln. So you can choose to pick the key in your calculator. You're going to get the same answer. So if you choose the log key, you'll get the same exact answer as if you choose the ln key. It doesn't make any difference to me which one you pick. So for the first example, we're actually going to do both of them. We have log base 3 of 5. So I'm going to use log base 10 first, and then I'll do log base e, or ln, second. The argument is going to become the numerator. I'm going to write this as log base 10 of 5. And the base is going to become the denominator. I'll write that as log base 10 of 3. So now I'm going to switch to a calculator, and I'm going to type this as log 5 divided by log 3. And you can see off to the right, my answer is 1.46497, so we'll leave that as 1.46. So this first method that we just went over, we're using log base 10. For the second method, I'm going to use ln, which is log base e, also in your calculator. So I'm going to do this the same way. I'm going to start with log base 3 of 5. That's our original problem. I'm going to write this as ln of 5 divided by ln of 3. Switch to a calculator. This time I'm going to type ln 5 divided by ln of 3. And you can see off to the right, our answer is still 1.46497. So it didn't matter if we chose to do ln or if we did log, we ended up with the exact same answer both times. So I guess you can pick whichever one you feel more comfortable with. It probably doesn't matter to you either. It is just a calculator button, but pick one of them and stick with it. All right, number 2 is log base 1/2 of 6. Also not a convenient function to solve for. So we're going to rewrite this using our argument of 6 in our numerator and our base of 1/2 in our denominator. Type it into our calculator. And off to the right, our solution is negative 2.58. Okay, and here you can check your answers on your own, so just try those by yourself. And let me know if you have any questions.